The analysis here. So let's say we are giving this circuit. We have this circuit. So now, let's say we are giving this circuit, a very simple circuit like this. So, how many nodes do we have? How many nodes do we have?
One.
Node.
Wait, is it like the one we have to make a decision or just connection?
Yeah, any way you understand node.
One. Two.
How many nodes do we have?
Two.
Three. So we are the three nodes. Yeah. One.
Wow.
This is a node.
Yeah. Yes, it's finished.
Wow, they are counting ground.
It's here and here. Right.
Okay. Three.
So these are the ones. Three nodes. They are what?
Be confused. Why is that number one?
Yes, yeah, that one is one there.
This is the branch. Yes or no?
Yes.
This is another branch. Yes or no?
Yes.
So where the junction where two branches are connected is called what?
Okay. Oh, you see now getting bright again.
So do we get it now? But how many node voltage do we know? Out of the three voltages now, how many node voltage do we know?
Two.
How many node voltage do we know?
One.
And what's the one? Zero.
And one now.
Wow.
Is it only one?
And one too.
One. What's the voltage here?
The same as V.
Exactly.
Yeah.
So, since there is a voltage source here, automatically the voltage, the node voltage becomes what? V. Yeah. So, which one is the unknown? So let's leave it as V. So, how will I say it? Like basically, we will start looking for the what? Case here, we will start looking for the node equation, right? So let's try to look for the node equation. Then I'll now show us the
KCL,
simple
KVL.
method. KCL, node analysis. Then I'll now show you the simple method I'm talking about. So as node 2, using KCL. So what's KCL? The current entering out, right? The current entry must be equal to the current coming out, right? The current is coming from here into the node and it's going out, right? Yes or no?
Yes.
So what are we going to have here now? We are going to have what? Let's say this I1, I2, I3. I1 equals to what? I2 plus I3, right?
Yes.
And then I1 is equal to what? You know that our I1 is the current passing through R1 and So I1 will be equal to what? It's supposed to be V over R. So what's V across R1? The voltage here minus the voltage here. Because it is in between two voltages. So you will not just use one for it. It will be the subtraction of these two. And then the direction of the flow is where you take it from. So it's flowing from here. That's why you have V minus V2. So we have what? V minus V2 over what? R. And then I2 is equal to what? V2 minus 0, because it is equally also between two nodes, but we know that the node voltage here is 0. So V2 over R. This one is R1. R3, that's V2 over R3, right? And I3 is what?
I3 is V2 over R2.
V2 minus 0 over what? R2. So if we put this into the equation, we have what? V minus V2 over R1, right? Equals to V2 over R3 plus V2 over R2. So if we separate this, we have V over R1 minus V2 over R1, right? Equals to V2 over R3 plus V2 over R2. So
Sorry.
let's try and make V2 subject of formula. Bring this one in. So V over R1 equals to V2 over R3 plus V2 over R2 plus V2 over R1, right? So we have V over R1 equals to V2 into brackets 1 over R3 plus 1 over R2 plus 1 over R1. So if we bring this one, if we equate it to 0, we are going to have, can I rub it off? The fact.
In this case whereby now I1 is not
You know, so supernova. Can you give us examples?
Depends on the direction.
So we want to
let us say I happen to
If this one is
Yes.
going out,
Now.
then you have I1 plus I2 plus I3 equals to 0. Because no current is entering here. It's not that to give the same answer. You have something to work with like that. So you can use all this method and get your answer. Do you understand? Can we continue? Can I rub it off? Quickly.
sorry.
So you can see how many hours, how many minutes it's taking us to derive the equation, right?
You already doing pilot.
After this, you have
you
It was just for the test.
Are you true?
When?
So if we make,
I think was it last week or so.
if we equate this to 0, what are we going to have? V2 brackets 1 over R1 plus 1 over R2.
You already even read all this. You have read the
1
past
over
questions.
R3, then minus V over R1 equals to 0. So these are our equations for the node, right? You can see how many steps we went through just to get this one. Then before you now start solving.
Oh, sorry.
But I want to show us one
So you can just ignore that. Just
method I use. Since you are writing CPT, are we true?
negative I. I'm going to have to positive I. This one do the simultaneous equation. Just cancel out. Exactly. So you can just pretty much ignore that.
And one thing I want us to note, one thing I want us to
You
note,
want to actually draw diagrams. You can just like put this note here, put this here, and ignore that one. So it's not like
Why you answer like real life diagram?
My neighbor.
are we true?
Come on, give me special ways. This one. This is coming down. And it's going to be negative.
yeah. On my own convention, I don't know if it's like this.
Are we
That's
true?
arrow like this. So my own, like, since current is going down, it's following
Yeah, the
this.
current is going like this. Okay, yeah, this is the voltage. It's going like this.
Yeah.
That
So
means
this one is
Can we
200.
continue?
And this one, V1 now is 0 over 1, so V1.
Are we true?
This one should actually be minus I, because this other side should be plus I.
wait, yeah,
Still
So one thing I want us to know,
is this,
we know there is a positive and negative terminal. So likewise, our parameters cannot be positive all true,
So actually, this
and neither can they be negative all true. What do I mean?
it's going to be.
If your V over R1 is negative in equation 1, it will definitely be positive in equation 2.
because we can say like this.
So if you have negative and negative, your equation is not correct.
So this I. So
Do you understand what I'm saying? This equation 1 now, we have minus V over R1.
Let
I think
me
we had another equation now.
sorry.
To make sure that your equation is correct, your V over R1 must be positive in the next equation. Your V over R1 cannot be negative in the two equations. If it's negative, then it's not correct. Because there is a positive and negative terminal to every element. Likewise, the parameters passing through that's your current and voltage will also be what? Negative and what? Positive. So when you